So the next part of the section involves integration of functions involving tangent, secant, cotangent, and cosecant exclusively. If they're mixed with sine and cosine, you can take care of them differently. What I've done here is I have made a list of a whole bunch of ones that you should know. These first ones are just taken from Cal 1. Basically, remember that the derivative of cotangent of x is negative cosecant of x. So when you take the integral, negative cosecant squared. When you take the integral of cosecant squared, you'll just get negative cotangent. The next one, just recall that the derivative of cosecant of x is cotangent, negative cosecant cotangent. So whenever you take the integral of cosecant cotangent, it'll be negative cosecant. You'll spend a lot of time switching this to sines and cosines if you're not careful without really realizing that the answer is just from Cal 1. The next one, secant tangent. If you take the integral of that, remember that the derivative of secant of x is just secant tangent. And then the next one, integral of secant squared of x, it's not tangent squared, it's just tangent of x because the derivative of tangent of x is secant squared of x. This next one is taken from, actually, this is from u substitution. Remember, tangent is also known as sine over cosine of x dx, and then you would let u equal cosine of x. Du is sine of x dx. And then you just take it from there. It'll end up being the natural log of secant of x, absolute value secant of x. Same thing here with cotangent. You can make this cosine over sine, and then take it from there using u sub again, u equals. This next one, secant x dx, let's derive this one real quick. This one, there's a trick to this one. When you take secant of x, you can write that as secant of x times secant x plus tangent x over secant of x plus tangent of x. All right, and then what you can do then is make this secant squared of x plus secant tangent of x, secant x tangent x, over secant x tangent x. Sorry, that's secant x plus tangent of x. And then what you can do then, when you're taking the integral of this, this is a trick. I would not expect you to just pull this out of your head, this piece here. Just multiplying by 1, basically. All right, so we have a dx here. If we let u equals secant x plus tangent x, then du, we're going to see that this comes out of it. Du is secant x tangent x plus secant squared of x. That's just, if you look at it, that's just the numerator. So we get integral of du over u, which then is the natural log of absolute value of u, which then is the natural log of what we had u represent, which is secant x plus tangent x. And then it's plus c. And there you have it. So that's how you get that. It comes up enough that you need to know this one. So please memorize this one. And then cosecant is similar. All right. Let's get to some actual problems, though, that you might see that are from, well, you'll see those too, but then these are more from like this section. What you're going to do here is you're going to be using the formula from trig, tangent squared plus 1 is secant squared. And then the other version of that would be secant squared x minus 1 equals tangent squared of x. So if you look, that first one that you have, the 9 integral tangent squared of x dx, you can make that 9 integral secant squared of x minus 1 dx. Now, split that up into 9 integral secant squared of x minus 9 integral dx. Then you're going to get the integral of secant squared is just tangent because the derivative of tangent is secant squared. So this is 9 tangent of x minus 9x plus c, and there you have that. The next one up here with the 8 in it, first of all, I'll pull out the 8, and then I'll pull out a tangent squared of x out of the interior. 1 plus tangent squared of x dx. This now is just secant squared. So you can get 8 integral tangent squared x secant squared of x. And then if you let u be just tangent of x, du is secant squared of x dx. So then all of this here is just du, and we have u squared du as our integrand, our new integrand, using u instead. So it's 8 integral u squared du, which is 8 over 3 u cubed, but u cubed is tangent cubed of x plus c. There you have it. Now if you look at the next one up here, this one here, let's try this one. Now these are kind of tricky. They're not always obvious how to do them. Pull out the 8, of course. You can make this tangent squared x, tangent x, secant x, dx. And then if the tangent squared you can make into secant squared of x minus 1 from trig, tangent secant. And then just what you can do is you can let u equal secant x, then du is secant tangent. All right, so then all of this here is just your du, and now this is u squared minus 1. And so your integral then becomes 8 integral u squared minus 1 du, and then you just finish it from there. The last one that we can look at here is this tangent squared secant x. This one's fairly difficult. So the first thing we need to do, we're going to get secant cubed out of this somehow. I'm going to go ahead and derive this one. Secant cubed of x is integral of secant x secant squared of x dx. I'm going to use parts, letting u equal secant of x, and then dv equals secant squared of x dx. Then du is secant tangent, and then v here, all right, so v here is just tangent of x because the derivative of tangent is secant. So when I do uv minus integral v du, I get secant tangent minus integral secant tangent squared, secant x tangent squared of x dx. All right. All right, so now what I can do with that is I can make this, so all of this is equal to integral of secant cubed of x dx. And then so I can make this one, this is equal to secant x tangent x minus integral secant x times secant squared of x minus 1, x minus 1, and then dx. Now this is minus integral of secant cubed of x minus secant x, integral of secant x. This is all dx here. dx, and we have secant x tangent x. Now notice what we have is we have secant cubed x on this side and secant cubed x on this side. If we take this and we add it to both sides, remember this is just secant cubed of x dx on this side on the left. If we add it to both sides, we get 2 of these. 2 integral of secant cubed of x dx equals secant x tangent x minus integral, I'm sorry, this would be a minus, this is actually a plus. So plus integral of secant x dx. Now, this one here, the secant x here, we found out to be natural log of secant x plus tangent x before. All right, so this is plus and then equals secant x tangent x. All right, and now we'll pull the 2 over. And so what I'll do then is multiply both sides by a half. So multiply all this by a half. And so we get integral of secant cubed of x dx equals 1/2 times secant x tangent x plus the natural log of secant x plus tangent x. All right, plus your c. All right, so then what we need to do is we need to go back and look at what we had originally. We had that tangent squared secant x. So do this in a different color. So this was 9 integral tangent squared of x secant of x dx goes there. And then so what we have then is 9 integral secant squared x minus 1 secant x dx. So that's 9 integral secant cubed of x minus secant of x dx. This is equal to, the first one is integral of 9 of secant cubed, which we found from below, and then we have the integral of secant x. So I'm going to put all this together. So I just wrote it all out. Essentially what we have is this piece here is from below. It's this down here. And then this piece here is from here. That's just the integral of secant x. And so when we do this, we get equal to 9/2 secant x tangent x plus 9/2 natural log of secant x plus tangent x, and then minus 9 natural log of secant x plus tangent x. 9/2 minus 9 is negative 9/2, so we get 9/2 secant x tangent x minus 9/2 natural log of secant x plus tangent x plus the c. And so you can pull the 9/2 out and finish this up. This is 9/2 secant x tangent x minus natural log of secant x plus tangent x, and then plus c, and that finishes it out.